Welcome to the examples for section 1.6. I'm going to do problems number 10, 22, 30, 39, 44, 59, and 60. That should cover all of the problems that we're going to be doing in class and also what you should see in the homework. So when we have an absolute value equation, we have to solve it we have to basically try to figure out for the possibilities where there's positive or negative. And so for this one here, I'm going to solve it as 3x is equal to 12, or I'm going to solve it 3x is equal to negative 12. So don't forget to do this when you solve these. Students usually forget to do the negative part of solving this equation, absolute value equation. So at this point in time, I'm just solving two linear equations. So I divide both sides by 3 here on the left side, and I get that x is equal to 4. I repeat the process here on the right side. So 3x is equal to negative 12. Divide both sides by 3. And I get x is equal to negative 4. So my solution set is negative 4, 4. And those are the two possible solutions, or the two solutions to the equation given in number 10. So number 22 is the same process. So I'm going to go ahead and write it equal to 1. But I also have to solve it as if my equation was equal to negative 1. And so the first thing I'm going to do is I'm going to add 1/3 to both sides. I'm also going to rewrite x divided by 2 as 1/2 x. That's their equivalent. So here I get 1 plus 1/3. Here on the right side, I get negative 1 plus 1/3. So what I'm going to do is I'm going to rewrite the 1 as 3 over 3. All right, I'm just going to go ahead and do both of them at the same time. So that's negative 3 over 3. And so I get 1/2 x is equal to 4/3. And here I get 1/2 x is equal to negative 2/3. So now what's going to happen is I'm going to multiply both sides by 2 since my coefficient is a fraction. I can multiply both sides of the equation by the reciprocal, which is 2 over 1, or just 2. So here I end up with x is equal to 8/3. And on this side, I get x is equal to negative 4/3. So my solution set is negative 4/3 and 8/3. For number 30, again, I'm going to do the same thing. I'm going to solve it for positive. So it's x squared plus x is equal to 12, or x squared plus x is equal to negative 12. So since it's a quadratic, I'm going to go ahead and set it equal to 0. So I get x squared plus x minus 12 is equal to 0. And I get x squared plus x plus 12 is equal to 0. So just looking here at the right side, if I were to factor this, which is what I'm trying to do, I would look for factors of, let me rewrite that, it should be 1 and 12. 1 and 12, 2 and 6, 3 and 4. And so what I'm looking here is, are any combinations of the factors for 12 going to give me a positive 1? And I can see that none of them will give me that. So for this side over here, there's no solution where x is a real number. So for this one here, there's no solution in the set of real numbers. So here on the left, again, I can repeat this process, which I did here. And so looking at the 3 and the 4, you can see that if I have a positive 4 and a negative 3, and I'm going to go ahead and write it here. So x plus 4, x minus 3 is equal to 0. So if I were to FOIL this, just so you can see it real quick, x times x is x squared. X times negative 3 is negative 3x. 4 times x is 4x. And then 4 times negative 3 is equal to 12. And you can clearly see here that I end up with a positive x. And so factoring x squared plus x minus 12 yields x plus 4 times x minus 3. I'm going to set each one of these equal to 0. And I get x is equal to negative 4 and x is equal to 3. So my solution set is negative 4, 3. All right, for number 39, we have an absolute value inequality, and it's a greater than. When it's a greater than, we have to solve it the way it is. So we get rid of the absolute value symbol. So it's 3x greater than 12. And we also have to solve it if it was less than negative 12. So similar to an equation, you have to do the positive and negative. You just have to flip the sign. So, of course, this one is pretty straightforward. We're just going to go ahead and divide both sides by 3. And we get x is greater than 4. And then here we do the same thing. Divide both sides of the inequality by 3. And we get x is less than negative 4. And so if I had a number line, I would put my negative 4 here. I'm just going to put 0 here just for reference sake. And then you can clearly see that here, x is less than negative 4 means it's going to the right. And since it's a less than, it's going to be a parentheses. In the textbook, this is the way the textbook does it with a parentheses. Some students might have seen it with an open circle. X is greater than 4, right? We're going to do that. And if we follow the way the textbook does it, is a parentheses. Or some of you guys might have seen it with the open circle. So the or becomes a union, right? And so here we get negative infinity to negative 4. Union 4 to positive infinity. So the solution set for the absolute value of 3x greater than 12 lies in negative infinity to negative 4, union 4 to positive infinity. All right, number 44. Whereas number 39 was greater than, number 44 is a less than. So the way that we solve this absolute value inequality is we write it as such. So we're still doing it negative and positive. So you can see that we end up with negative 7 less than or equal to 2u plus 5 less than or equal to 7. Number 39 was a greater than, and so you have to solve it greater than the value they gave you and less than negative, the opposite of the value they gave you. So here what I'm going to do is I'm going to subtract 5 from the left, the middle, and the right, which will give me negative 12 is less than 2u is less than 2. And then I divide all 3 parts by 2 to get negative 6 is less than u is less than 1. And since it's a less than or equal sign, I'm going to get a bracket. So the solution for number 44, absolute value of 2u plus 5 is less than or equal to 7, lies in the interval of negative 6 to 1, including the endpoints negative 6 and negative 1. All right, number 59, we have the absolute value of 5x is greater than or equal to negative 1. And so the solution set for this one is all real numbers. And the reason being is that no matter what I choose for x, it's always going to be greater than negative 1 because the absolute value of an expression or value is positive. So therefore, is for this particular problem is all real numbers. Now, sort of related to number 59, number 60, this is less than, absolute value of 6x is less than negative 2, sorry. And so this is no solution. For the same reason that this is all real numbers, this is no solution, because regardless of what I choose, right, if I choose negative 2, and you're going to see that I get negative 12, which is equal to 12, and 12 is greater than negative 2. So no matter what I choose, what value of x I choose, it will always be greater than a negative number. So number 60 is no solution. Number 59 is all real numbers. And that's the end of the examples for 1.6. Thank you.